Okay, so close them all the way up, please. All right, what do we got here then? So how many layers do we have on this thing? What's the outside layer? Cosine, right? So let's write this down. Okay, so first layer then, if we're going to calculate y prime.
Miss Thomas, can you call 3801? Miss Thomas, 3801.
First layer is going to be, the derivative of cosine would be negative sine of whatever's inside. Okay, so we'll erase that first layer. Took care of that. So the next link in the chain, what do we got there? Gabe, what's that derivative of? Say it again. Exponential. Okay, so what's the derivative of e to the u? Okay. Okay, so now we get rid of the exponential part. And now what is it? Maisie, what do we got? You do. So that'd be negative 10 theta to the fourth. There we go. Okay. So all we really would need to do here then is just maybe pull that stuff out front and that's it. Right? Negative times negative would be positive. We'd have a 10 theta to the fourth out front. I'd put the exponential out front too. But none of that is required because it doesn't tell you to simplify. So that's what they had. Yep.
When do you use the u times
We did here, right? We did. We took the derivative of e to the u times u prime. There's e to the u, and there's.
Oh, okay.
You get what I'm saying? So there's u prime.
Okay. Gotcha.
Okay. All right. So what about this one? Kind of ugly.
Let's simplify it to x to the third.
Okay, that's a good idea. Good idea. So Eldon makes a really good point here. We could look inside this function, and we could actually simplify that, right? And that does make it easier. I could factor a t out of the top and a t out of the bottom and cancel those, right? So we could rewrite that as t cubed over t to the fourth minus 3 to the fourth. That does make the quotient a little easier than that, doesn't it? Right? So how many layers are there to this one? Essentially, 2. Outer layer is power, inner layer is quotient. Okay? So if we want to calculate y prime, first layer is going to be told me power. So what's that? Okay, so 4 times hand or u cubed. And then we have to just do inside of that, we've just got a big quotient, right? So we have to use the quotient rule. Okay, so what's going to go on the bottom of the quotient rule? What's going to go on the bottom of the quotient rule? So we forget that.
T to the fourth minus
Squared? Okay. What's going on top? Joe, what goes on top? You got to be careful with the quotient rule, right? The order matters in the quotient rule.
Isn't it u prime b minus this? It's the other one.
So we got to
Okay.
get.
So it's u times v prime minus u prime and t.
Okay, backwards. Right.
Well,
Low
that's
D
what I
high.
just said.
No, it's
That's
low
like-
D high.
No, the first time I said, okay, whatever. It's fine.
So
Okay, but I.
so
is-
V
oh.
V du.
So
V u
v
prime.
times u prime?
Mm-hmm.
That's, okay. I said it.
Right. So V u prime. So we're going to get t to the fourth minus 3 times what? 3t squared. Minus, you gotta get a minus in there, that's why the order's important. What? T cubed times Okay, and so do you see why that was really a good idea to simplify this? Because then when we take the derivative of the bottom, we don't have a t there. We kind of clog things up, right? That really did help. So that's our answer. All we really need to do here, I mean, I don't think you really even have to be too fancy about combining this stuff, but let's just take a second and see how we could. If I'm taking a quotient to a power, we can just separate that into the power of the top and the power of the bottom, right? Property of exponents. So we could write this as 4 times t cubed. Cubed is what?
9.
T to the 9. Take a power to a power, we multiply exponents. And then we'll simplify that in a second. On the bottom, we're going to get t to the 4th minus 3 cubed, right? Times t to the 4th minus 3 squared. Everybody see that? So what's that going to be? To the 5th, good. You multiply like bases, you add the exponents. So we just distributed that to both the top and the bottom. And we get a t to the 4th minus 3 to the 5th on the bottom. And then all we have to do is just get all this stuff distributed and simplified. So what's that going to give us? If I distribute the 3t squared, I'm going to get what? 3t to the 6th minus 9t squared minus 4t to the 6th. So if I combine like terms, what does all of that become?
Negative t to the 6 minus 9.
That's it, right? If you want to take the negative out front, you can do that, but you don't have to. Okay? Make sense?
Yeah.
Okay. Second derivatives. You got to look at these carefully, right? This one's asking for a second derivative. So first derivative is just a cotangent of u, right? So what are we going to get for our first derivative? Got my 1/16. What's the derivative of cotangent u? So negative cosecant squared u times what? Your cotangent u is negative cosecant squared u times u prime, which would be 4. Okay. So what do we do? I guess we just take the negative out front. 4 over 16 is 1/4. Okay, so there's the first derivative. Now we just have to differentiate again, right? So the second derivative, how many layers are there to the function there?
3.
3? Okay, what's first layer?
The square.
Power. Right, we have something squared. Second layer is cosecant something. Third layer is u, whatever's in the middle, right? So let's differentiate that. I'll write that down. Just remember that cosecant squared really means that, right? So then y double prime, we've got our negative 1/4 out front. The derivative of or something derivative of u squared is, okay, so we get 2 times u, which is cosecant, times the derivative of, if we get rid of that layer, so we took care of that link in the chain. What's the derivative of cosecant u? You not remembering these?
Cosecant.
It's going to be negative
Cotangent.
cosecant cotangent.
Yeah.
Okay, and then so that takes care of the next layer. And then the derivative finally, then finally the last layer, what's the derivative of u? 4. Okay, so what do we get then? 4 cancels with this, I've got a negative and a negative, so I've got a 2 out front. It's left over, and then I just have a cosecant times a cosecant times a cotangent. So what's that gonna be?
Cosecant squared, 13.
Right? Okay. And then last one, tangent line. So we want to find the tangent line to the curve at the point x equals 5. So we just need a point of tangency and a slope, right? What's the point of tangency going to be? 5 something, right? If I evaluate the function at 5, we're going to get square root of 25 minus 5 plus 5, square root of 25, which is 5. So there's my point of tangency. How am I going to find the derivative?
Again,
Just got to take the derivative. So I got to find the derivative function first. So we've got 2 layers there, don't we? Right? We've got a square root, so a 1/2 power of a polynomial. So derivative of square root of u is, what's that going to be? Okay, good. So that's a 1/2 power. Derivative of hand to the 1/2 is 1/2 hand to the minus 1/2, which is a square root on the bottom. So there's the first layer, and then we just have to differentiate what's inside, right? So what's inside is just that polynomial. What's the derivative of x squared minus x plus 5?
2x minus 1.
Good. So we end up, and do I need to simplify that?
no.
No, don't waste your time, because we're just gonna evaluate it anyway, right? We wanna find the derivative when x is 5. So the slope of the tangent line is equal to y prime when x equals 5. So if we evaluate this, we're just gonna get, if this is on top, we get 2 times 5 minus 1 divided by 2 times the square root of 5 squared minus 5 plus 5. So what do we get? 10 minus 1 is 9 over 2 times 5 is 10, so 9/10. Did I do that right?
Yeah. We can just do it like this when you test?
No, it wants you to write it, right, you're filling in the blanks. You gotta write it in slope-intercept form. So what would we get then? We had y minus, the y coordinate was 5 equals 9/10 times x minus the x coordinate was 5. So this is just algebra 1. Then we'll just distribute the 9/10. 9/10 x minus, what's that, 9/2? So add 5 to both sides, and what do we get? So negative 9/2 plus 10/2 is 1/2. Does that make sense? We're pretty fast here. I just want to give a chance, time to work. Okay. We good? Go. Go. Got a practice test up. You might want to just look at those.